Acquisition Committee for inviting me to deliver this talk. I'm basically a material chemist, so you will see a lot of chemistry. We do synthesis of blood copolymers and telecalic copolymers for the delivery of different types of drugs. But my expertise are more on the synthesis, so you will see quite a few chemistry in there. I come from University of Alberta, and University of Alberta is located in Edmonton. So in summer, this is a beautiful city, but in winter during this time of the year, we used to see a lot of snow. This year we have not seen snow so far. That's a good news for us. Probably the global warming is working for us. You've heard quite a few presentations about the drug delivery, the nanocarriers, and then I will talk about some of the telecalic nanoparticles synthesized using the in vitro encapsulation and release behavior of those nanoparticles. It's very important, in addition to the other factors, the hydrophilic, hydrophobic component of the nanoparticles. So, considering the first investigation, the drug encapsulation efficiency and drug loading content were not very high, so we decided to use a block copolymer synthesizing from the hydrophobic block using fatty acids, and creating the second block with the pH-sensitive polymer. So we use this for encapsulation and release study. Okay, so drug delivery, we've heard quite a few presentations about it so far. The central target is the optimum dosage. And for the optimum dosage, we have to use different carriers. And there are certain specific challenges associated with this. So we need to consider drug property, its molecular weight, stability, solubility, etc. But also the administration route, whether we are doing it oral or through transdermal. Then delivery vehicle is very important, whether we are using polymer, nanovesicle, nanorods, or whatever. Its size and shape plays an extremely important role. Then we have the release mechanism, whether we want continuous or modulated release. Then is the targeting, whether we want organ, tissue, cell or cell component to be targeted. And one of the very important parameters is biocompatibility. If nanoparticle or nanocarrier is not biocompatible, that will be recognized by RES system and eliminated. So these are some of the challenges which are associated with the design of nanocarrier. And the ideal drug delivery system should serve several different kind of purposes. So, for example, it should have the ability to target the cells, and more importantly, intracellular targeting, because now we're moving from tissue to cell and cell to cell components. It should load certain specific amount of therapeutic, because if the loading content is very low, then we have to have much amount of the nanoparticles, and they have their own drawbacks. And also, if we have imaging system, that is very important for tracking. So overall, we have several challenges, and we can see that there is a huge number of carriers being used these days. We have the solid lipid nanoparticles. These are quite few being used, but these are new. Dynamers have been investigated and still being investigated. They've been in the market since quite a few years. Hydrogels, vesicles, emulsions, now, and moistures also. Now these different types of carriers, they have their own positive and negative effects. When I say negative effects, they have quite a few limitations. So we choose carrier based upon the requirement and the purpose we need it for. Okay, so I will be talking about micelles. So micelles are basically the amphiphilic molecules which can self-assemble themselves, and we can encapsulate drug inside the micelles depending upon the system we are using. If we are encapsulating hydrophobic drug, it is possible to have inverse micelles to encapsulate different types of drugs. Most of the time these are used for the encapsulation of hydrophilic and less bioavailable drugs. So their water distribution is anisotropic, so if we have a micelle and the surface is highly we have highly hydrated surface, and as we go down to the core is most of the time highly hydrophobic, but the drug is distributed based upon the type of the micelle, its hydrophobic to hydrophobic component, and then most of the time hydrophobic drug is at the core, but there are the drug is also present at the intermediate level. So most of the time that's very important to understand the micelles. Their release behavior is one of the challenges